The Labster solar power plant is the next step in the huge effort to reduce carbon emissions and creating a future where sustainable energy plays a key role. This facility is located in a desert and its pure purpose is to harvest solar energy to power cities. Evercam Energy Storage System plant, owned by Evercam, plays crucial part in this effort as it is the component that converts and stores the harvested solar energy as chemical energy. This action is important to allow it to be transported to cities where it is converted back to electrical energy for industrial and residential purposes. However, the major obstacle that lies in this brilliant idea is the determination of chemical compounds which are most suitable for efficient energy storage and transportation. Octane is among the proposed solutions to this problem due to its high energy density and compatibility with existing infrastructure. Laws of thermodynamics are deeply looked into in order to help us find a solution with this problem. The first law of thermodynamics, or also known as the law of conservation of energy, states that energy cannot be created nor destroyed, but it can be transformed from one form to another. This law helps us in the transportation of the solar energy, which we convert to chemical energy so that it can be supplied to far places such as the cities. This is where the chemical compounds such as octane is very important. The challenge lies in optimizing the efficiency of the energy conversion process and minimizing losses during transportation. The second law of thermodynamics states that in any energy conversion process, the total entropy of a closed system tends to increase over time. Entropy refers to the measure of the system's disorder or randomness. This law highlights the importance of designing energy storage and conversion systems with maximum efficiency to minimize the generation of waste heat and increase overall system performance. The selection of octane is to adhere to the said objective. On the other hand, cost, safety, and environmental impacts related to octane production from carbon dioxide must be looked at because it is of the paramount importance. Taking all this into account, a better and cleaner way to convert and transport the solar energy must be implemented so that the clean solar energy that is harvested doesn't become impure by transforming it into a chemical energy that is not environmentally friendly. There are two problems that are faced based on this scenario. The first is travel distance. The solar energy that is harvested in the desert cannot be directly transported to the city as the distance between the city and the desert is far too long. The second problem is transformation of energy. Three other chemicals besides octane need to be determined to store the chemical energy that has been converted from solar energy in order for it to be transported to the city. As for the objective of this assignment, the first is to determine another way to transport the electrical energy harvested from the solar power plant. Other than that, discovering the most suitable chemical compound for energy storage and transport by comparing the compounds based on certain criteria is another objective. The last objective is that we should perform data analysis on the chemical compounds that have been discovered, which is very crucial to this assignment.
So now we will look on the methodology. For every compound, we did some calculation in order to know its specific energy and energy density so that we can determine the most suitable compound for our goal. So the first step that we did is find the molar mass of every compound. Next, the second step is we determine the heat of combustion for every compound. The third step is we calculate the specific energy. So, specific energy can be found by dividing the heat of combustion by the molar mass. The fourth step is we calculate the energy density. So before we can proceed with the calculation, we must find the density of the compound first. Then we can proceed with the calculation. To calculate the energy density, we just multiply the specific energy with the density that we obtained just now. So the methodology and the result may vary depending on the specific condition and purity of the compound itself. So to determine which compound that can be used and the most suitable for energy storage, we will choose the one that the most environmentally friendly and the one with high specific energy and energy density. Data analysis on proposed solution. When we observe at a proposed solution, in order for energy storage using chemical compound to be efficient, we need to use an organic compound that contains high specific energy, high energy density, and environmental friendly, so that it can accommodate more energy and safer to be used. The first compound is formic acid, HCOOH, with a specific energy of 26.6 megajoule per kilogram and energy density of 3.3 megajoule per liter. Next up, the second compound is methanol, CH3OH, with the specific energy of 22.7 megajoules per kilogram and energy density of 19.9 megajoule per liter. We proceed with the third compound, which is octane, C6H16, with the specific energy of negative 47.9 megajoule per kilogram and energy density of 32 megajoule per liter. The negative signs indicate that the specific energy is being transferred out of the compound. And lastly, the last compound that being proposed is ethanol, C2H5OH, with a specific energy of 29.7 megajoule per kilogram and energy density of 26.8 megajoule per liter, which is the most reliable and efficient among all compounds that we propose. We do believe that ethanol is the most suitable for energy storage.
Sustainable energy is becoming more and more important today because of the effort to save Mother Earth by reducing carbon emissions and the problems that come with it, such as global warming, a rise of sea level, and depletion of ozone layer. Therefore, solar power comes in as one of these alternatives as it is an renewable energy which is much cleaner compared to fossil fuel and nuclear-based energy. However, in order to fully curb the carbon footprint problem that we are facing today, everybody from every sector of every industry should find a way to make processes that occur more greener and environmentally friendly so that the impact that is sought for can be achieved much faster. We have only scratched the surface with the implementation of solar power, whereas renewable energy is a far bigger field involving hydropower, geothermal energy, biomass energy, wind energy, and many more. All world leaders and innovators should join hands and burn the midnight oil to come up with projects that optimize the usage of these energy to create a better environment for the future generations.